Our next speaker is Olaf Munkelt, and he is the co-founder and managing director of MVTec software, and he's going to be talking about embedded vision made smart, introduction to the HALCON Embedded Machine Vision Library. And I understand the Raspberry Pi is going to have a role in this talk, is that right?
To some extent, yes.
Okay, well, so this is amazing to me that you can take something that originally sold for $35, probably is less now, and actually do meaningful computer vision on it, and you're going to show us how to do that more easily than if you were doing it from scratch.
I hope so.
So, all right, well, good luck. Thank you.
Thank you. Yeah, good afternoon, ladies and gentlemen. I should have changed the title of my talk. So something like computer vision reloaded or machine vision is the older technology or something like this. So probably for those of you in the audience who have not heard about machine vision, this is a proven technology which is used in the industry since more than 20 years. And actually I'm coming from a company which provides software to machine vision since more than 20 years. Our software is an enabler in terms of it allows our customer to build their solutions. So we don't build the solution itself, we provide the tools actually. And these tools, they have a lot of common with the functions which we just heard, which are built on the ARM. I was very surprised to see this in terms of benchmarking. Benchmarking is something which in our industry we do since years. So there's a lot of reinvention. This is my feeling, what I see here. And I like to take you a little bit on the other side. I hope the bright side, not the dark side. The bright side of what machine vision has already done. Our software has been using in semiconductor industry for web inspection, for quality control. And it's used in many different areas as well, in agriculture, in pharmaceutical, and of course in factory automation. The product I would talk about and give you a little glimpse of what the power is HALCON. HALCON is a software library actually, and it comes with an integrated development environment which allows customers to easily set up machine vision application, also computer vision applications, by the way. There's not much difference for certain type of applications and technologies. HALCON is running in hundreds of thousands of installations worldwide, so it's broadly used in industry, in the production industry, but also outside the production industry. And we have heard a lot about embedded algorithms today. My take on that and MVTec's take on that since years is very straightforward. If you have an algorithm which runs on the PC, it should also run and deliver the same result on an embedded device. So we have ported HALCON to many different devices, including TI DSPs, and also, I don't know who's old enough in the audience who knows what a Hitachi H4 is? Ah, some people do, okay. So we brought also part of HALCON's algorithms to this very old CPU. So we have a lot of knowledge about software engineering and a CPU or an embedded system. There's not much difference for us from a computer science perspective. You look at it and you take the algorithm and you simply say the algorithm also has to run on there. So HALCON in that regard supports many different instruction sets because it has been requested by our customers. It supports, of course, AVX2, neon optimization, also TI-based optimization for some functions. It's an entire set, so HALCON Embedded, so to speak, is nothing else than HALCON just running on an embedded device. And also, we will provide a standard version for the ARM architecture very soon. So there is literally no difference. And I would personally be interested to do some benchmarking regarding this image filters from the colleague, the speaker before me. To get you an idea where HALCON is used, here in US, NASA is a very important administration. Also, it is very well known in Germany, I have to say. So NASA used HALCON on the ISS for the purpose of combining sensor data from different sensors, from cameras, from time of flight sensors, also from pressure sensors. So this was possible because HALCON features an extension package which allows to combine different data and still process this data within the integrated development environment which we have. Here you see a bunch of algorithms which are used in this application. We use texture segmentation, we use 3D calibration, because there's a stereo camera which is used. We use classification, so different technology has been used. And you see this is HALCON 9. This already a couple of years ago. Now we have HALCON 13, and it's still running and not crashing the ISS, so we are happy. Another application we took from, this is quality inspection, you want to say so, but this has been done in agriculture environment. We have to see that tomato seeds are produced on a very large scale in this world. We have more than 150 million tons of tomatoes produced in the world every year, and each of these seeds cost a quarter. If I convert this with using current exchange rate conversation. So there is value in it, and we have to make sure that only these seeds are continue to grow, which actually are able to do so. For that purpose, you have to measure these seeds, these little plants here. And this has been done in a research project, which has later been then implemented in a machine which is running now and inspecting 18,000 seeds per hour. So this is a real world application, and HALCON here is used for performing stereo calibration because in order to reconstruct the 3D structure of the seed, there are 10 cameras, and these 10 cameras need to be aligned very precisely, and we have to make sure that this also does not change over time. So another example where you have a kind of advanced application and you want to quickly set up a solution for it. And last not least, software, by the way, is just one piece of the solution. We also have to use industrial cameras in here. We have to use the right illumination. These are characteristics which are very typical for industrial applications. Here in the audience, in this setting here, I have the feeling that many real-world applications are more important. Let me dig a little bit inside what HALCON actually is. The core of HALCON is an image processing library, and this image processing library provides functions to the programmer. So it's a programming library. You call a Sobel filter, you call SVM operator, support vector machine operator, or Gaussian mixed model classification. So this is all included in there. And also it has, of course, functions for input and output. So you have to process an image. That means you have to get an image into the host PC or on the ARM, and then you have to deliver the result via an interface, which is something which is very important in industry. Delivering a result means then providing socket communication, serial communication, or OPC UA, which is a very popular communication standard in the industry 4.0 or industrial Internet of Things scenario. So HALCON provides a lot of functions, and we just saw some 40 functions I heard in the OpenVX talk. I saw some 24 functions on the ARM talk. HALCON actually provides more than 2,500 operators, which cover all different kinds of low-level, medium-level, and high-level functions. So the questions for me, if I look at my colleagues here, is very straightforward. What are the functions which we provide, which we do not provide, so to speak? So the more interesting question is what HALCON can't do. And to give you an answer on this before you ask me after the presentation, HALCON cannot do face recognition. Because as we started 20 years ago, there was a famous professor, Alex Pentland, who invented the first eigen faces that were the representation by that time, and he patented that. So there was for a very small company we were at that time, not possible to simply look inside this application. So we stayed away from this section. We also stayed away from the security market and video analytics, it's called in there. So we concentrated on the industrial side. And for that set of customers, we provided all the functions which they actually need. Some need more, some need less, but basically everything is included in there. And if you are more interested in what particular functions are included, you're more than welcome to go to our booth and talk to the real engineer, not to the managing director here. So the give you a more closer look in here. What are the typical applications which we see from our customer side and where we think they can also be very beneficial in what's nowadays called computer vision from a different perspective in here. We do have data code reading, we do have barcode reading. You may say this is on your device. Well, this is very true, but you take your device in your hand and you move it around. Moving it around basically means you adjust so the algorithm finally can read it. In an industrial setting, very often there is no way that you also buy a robot which moves around the camera in order to read the data code or barcode. It has to simply read it. So for that purpose, we have included, say, advanced algorithms which allows you to do this very robustly. 2D metrology, I was very surprised to see nothing about this. It basically means you measure subpixel precise distances and angles in an image. This is a core technology from our understanding. And it is a very proven technology, by the way, but it's only implemented in very specific libraries. Calibration is a core technology. No CNN will help you to do calibration. So I'm really sorry. I have close to 30 years experience in this area. And by the way, also CNN technology has a certain history. It's not just where 2 years ago or 3 years ago. Anyhow, we have matching technology, which is a core technology. You would probably say this is identification technology. That's okay. I don't mind. Let's have a closer look in this kind of technology. Matching technology, we provide 3D matching, so finding 3D objects by their geometric properties in an image by using a single camera, by the way. We have perspective deformable matching integrated, so if you have a plane object which can be just part of the objects which are in a certain plane, we are able to extract the 3D position from there. We have what we call descriptor-based matching. You can also use SLAM technology for providing a similar functionality. This technology here, like all other technologies in HALCON, optimize for speed, because this is very important. Speed counts. And for that purpose, we have choosing a different approach, also feature-based approach. We have extended these technologies to color images, because color plays a certain role in many applications. We have NCC matching, of course, and we have what we call component-based matching. So if the object in an image have different positions relative to each other, we can still identify all the object in one step. So you save some time while you do this. Let's have a closer look at HALCON itself, the library. It allows you to actually access the library from different languages, from C, C++, from C#, .NET, and you're basically free to choose your language, and you get the language appropriate interface. You get native classes in C++ in order to get you quickly started. I don't talk about all this memory allocation stuff and whatever I heard today. This is so basic to me, it's not worth mentioning it, that this is of course all part of the library. Another point which also surprised me a little bit, parallelization. Parallelization is a very old concept in computer vision. I'm sorry to say this, and I'm happy to emphasize that we have included this concept since, well, 17 years now, which means that we take an image, we look at how many CPU or how many kernels do we have on the actual CPU, and then we, for example, take the image, split it in 4 pieces, and process each piece on each core. So parallel processing, and the speed up which we achieve is very close to the theoretical maximum which we can achieve according to this particular algorithm. This is also implemented, by the way, throughout the library. So for this 2,500 operators, the 500 operators which are mostly used in machine vision, they all do this, they all perform this. So this is, of course, is also available on ARM architecture because they have many kernels. This is our understanding of providing a functionality from a user's perspective. The user doesn't care what kind of CPU is down there. He just wants to have delivered the performance of this particular hardware, and it's there. This was our understanding, and we did this since do this since 20 years. But this concept is also extended to if you have multi-channel images, like satellite images, for example, not only RGB images. It's also extended to image arrays or to region arrays. HALCON has a very powerful concept of region of interest, where you only process part of the image, and you also continue processing this part of the image. And also for contours, contours are 2D representation. And by the way, many algorithms in machine vision, they require more than integer operations. We use floating point operations very much. Multi-threading applications is also possible to develop within our integrated development environment, so that customers actually can perform different inspection tasks, visual inspection tasks, on a single image. So this is also something which we think is very important, and this integrated development environment allows us to make the development pretty easy. How do you get now to your application? Well, you integrate this, you export the code in the development environment to Visual Studio, for example, and then you compile and run the application. You have a runtime environment in order to do this. There's also another way to do this. If you have what we call HDEV engine, this is an interpreter. It interprets the single lines in the development environment, and he performs the same thing also in the application. By doing this, it's much easier to maintain an application and upgrade an application. And from our point of view, there's no difference whether you do this on a PC or whether you do this on a Raspberry Pi, so on an embedded architecture. The same thing, because HDEV engine, the interpreter which interprets the results, is also available on this device. And if we have a little look on this video here, you get an idea what it is about. So you assume you have 3 objects in the image, and you want to identify these objects, you want to count them. Here we start actually the shell on the Raspberry Pi, and we perform the application. You only see the output of the console because we have no window screen there. And you see it takes certain milliseconds over here to find one, if we only have one under the image. And now we have a second one under the image, so we found 2. And at one point we put a third in the image, so we should find 3. But we don't find 3, so something went wrong. And the idea now is to actually have a closer look. What is the reason for it? And for that purpose, we use HDevelop on the PC. So we start this on the PC, and we are now connecting from the PC to the embedded device. So the embedded device can be anywhere in the network. And the same thing also works, by the way, on a different PC. As this is a kind of tricky thing, we have to protect this by using this password over here. And then we see the actual code which is executed on the Raspberry Pi on our PC by using HDevelop over here. And we see, oh, there are 3 in there. And we couldn't find these 3. You see, this is a live demonstration because there's the hand in there. And we now have to take a closer look on what is the problem. For that purpose, we actually save the image. We save the image, yes, and we cannot actually modify the code on this Raspberry Pi in here. We have to do it like this, saving it, and then we load the same code which is on the PC and applying the image to this code in order to inspect, to debug the application. So we see in a second the code which is then loaded from the PC, and we load the image, we go there step by step. You see this environment here. We have a graphics window where we see the representation of the results. We see also the execution time of each single operator on the right side. This script code is very straightforward. It handles all the memory management side. And here we see what we have to change. This is a matching operator, and there's a 2. This is a hard limit, which we have to save to 3 in order to make it possible to find 3 instances. Of course, you can find any instances you like in the image. This is not a big deal. So what we now have to do, we have to save the modified program, and we have to upload this modified program by using this little tool here to the Raspberry Pi again. And this whole thing is done within a few minutes. So we stop the execution on the Raspberry Pi and then run the execution again. It loads the modified file, and then it performs the execution, and it counts 3 matches. So we are happy. This is a way which greatly reduces the development time for the developer and helps us a lot to make life easier for the developer. So how does HALCON actually secure your investment? It's focusing on the industrial applications, definitely, but it provides all the functions which are also used in computer vision. Documentation is something which is very important for many customers, for many users which are probably not the computer science super duper professional, which I think are around here. Maintenance is something which is very important. Every time new compiler versions come up from Intel, not only from Intel but also from Intel, the software, the source code has to be maintained, and is of course well known for its reliability. We do publish our error rate actually. I think we find something like 2 or 3 errors within 10,000 lines of source code in HALCON. So this is an excellent ratio, by the way. So HALCON protects your investment in terms of initial purchase. This is something which you probably don't have to do if you go for an open source library. But this is only half of the game, not even half of the game, because you have to get familiar with what you are using. You have to be sure that it is available for a long time on the market. You have to do the implementation itself. And the more source code you have, the more you work on the source code. It really costs you a lot of time and money. We have to have maintenance cost, as I mentioned earlier, to take into account. Last but not least, we have to take opportunity cost. If this does not work, what do you do then? Then you have to revert and do something different. And last but not least, you have a risk that the current vendor changes their plan or does not maintain something any further. We have seen this in the past, and this gets you to the total cost. So my wish is, if you build up a system, have a look at the total cost. Further resources, as seen here on this slide, you're also more than welcome to visit us a few meters down, a few yards down the down the aisle and get a more deeper insight in our technology. We have also running a HALCON Embedded demo live over there. So thank you very much.
Yes, go right ahead.
Thank you for the presentation. I've used HALCON on a PC environment, and I know it's license key based. So how would it be purchased for embedded application? Like how does the purchase work for?
It also has there is
license?
a dongle for embedded version. So if you don't have a USB plug, then you have to talk to our engineers over
I
there.
see. Huh? So it's the same idea with the
Same
dongle?
thing, same
Okay.
thing. Yeah.
Thank you.
Yeah, welcome.
Other questions? I have one question of my own, which is, what is the easiest way to get started with HALCON? Like if I were interested in it, your talk inspired me, what would I go do?
You simply go on the web and download that, register and download, and that's it. There's an evaluation key, so you can try it out for free. Straightforward.
All right, well, thank you very much.